This will be my last whip for the year, so it's a little nostalgic, I guess, to be in this position. But I want to give you all updates with regard to this project, a project that over the course of the year has been defrosted and then refrozen, and then defrosted and microwaved and then refrozen. But now it's really cooking, and I hope that you'll agree with me as you see the presentation. So I think everyone's heard the basic description of this project. What we're looking at is the association between community-level violence and asthma outcomes amongst children, specifically children of color. And so this is an image that I really like from one of the previous studies, and I've shown it before in my slides. The incidence of violent crime depicted in the circles and the underlying prevalence of asthma amongst the adolescent and child population within that police beat in Chicago. And so you can see a decent association between the areas in which there are high crime and the asthma prevalence. Specifically within this study, they found an odds ratio of 1.27, so 27% likelihood of asthma given high crime, and that's adjusting for largely individual level factors, including age, sex, family history, socioeconomic status, race, ethnicity. And the question of confounders and what we'll be controlling for, you asked at the end of my last presentation, and that will actually kind of be one of the major focuses of this presentation as we move on. And so in light of this study, which looked at this area level outcome in the police beat using survey data alone and not having really any individual outcomes for example, the severity of asthma amongst participants, we are moving forward and asking, the questions about, does violence exposure, which I'm calling CVE, for the purpose of this presentation, increase odds of asthma amongst children in general, specifically Latino children, as I'll continue in describing, and amongst children with asthma, does community violence exposure increase the odds of poor control, and does it increase the odds of poor pulmonary function? These are outcomes that we are specifically very, we're lucky to have. Past studies, though they've been larger, have relied on surveys. Has a physician ever told you or your child that they have asthma? And we have confirmed cases with really high quality outcomes that are clinically relevant. To perform this study, we've identified a sample population, and I'm going to commit a major error presentation and present to you a couple large tables rather than specific findings. But what I really want to show here is that we have a decent population, 275, within this one city of San Francisco. As we would expect to be the case, our cases are a little younger, our controls are older, and our cases are more likely to be male. Otherwise, within, when it comes to the other individual covariates that we might be interested in controlling for, they are statistically similar. Because we were losing too many participants to socioeconomic status specifically in terms of income, we will be using maternal education as our primary variable to designate SES status in the family. Also to point out, many of the studies that our lab has done have included both SAGE, being the African American pediatric population, as well as GALA, the Latino population. And unfortunately, we will only be able to use the GALA population. But I'm excited to see what that results in. The last row I've left blank because at the level of case and control, I have yet to really be able to quantify, and I don't know if I will be able to quantify, but I'll discuss how we will be assessing exposure as I continue. Please let me know if there are any questions along the way. So when we take this population of 275, 145 controls and 130 cases, and we distribute them geographically through San Francisco, you can see that the cases are the black dots, the controls are the yellow crosses. The controls will be crosses throughout the presentation. The colors had to change a little bit based on the maps that I was doing, but the crosses will always be controls. The two groups, I think, are situated with a pretty high degree of overlap geographically. This is something that when they were recruited wasn't planned. We were recruiting from clinics here in the city based on eligibility for other factors, but not geography. And I'll discuss the implications of this high degree of overlap as we continue. So that's our study population. With regard to our exposure, we've been through some of this before. This is all of the reported crime in San Francisco by category between the years of 2003 and 14. What I did using some of the literature to perform this consideration, I looked at crime that was greater than 50,000 over that 11-year period. Assault is here. Assault is one of the most commonly used variables in these analyses. You can see that the categories of crime that have a higher incidence than assault include larceny, theft, which is the highest bar. Is this working? The greatest incidence is larceny, theft. The next two are other offenses and non-criminal, which wouldn't really be appropriate for our analysis. So in my mind, assault is the second highest, most prevalent crime in the city. And it's one that, in described in the literature, it's of significant, it's something that you can see and therefore be more stressed out about. Whereas theft might be petty, it might be smaller, it might not cause the same kind of stress response in the observer as assault would.
Actually, sorry, if you go back, warrants is an interesting one, right? 'Cause I can see how that would be stressful for a kid.
Right. Yeah, I mean, it could be, like I said, assault has been used more frequently in the literature, so, but I can always further explore what proxy we use for violent crime exposure. Or rather, exposure to violence, we're relying on reported crime.
And is assault at 1-0, or is it, do you have a degree of assault by your reports?
So San Francisco reports assault. Within assault, there are multiple subcategories. I haven't seen anyone who's, it's pretty much binary. I haven't seen anyone who makes gradations of assault.
But wouldn't it be interesting if you had no crime, sort of like theft or vandalism, which is somewhat, sort of mild stress, and then assault, and you show that there's a dose response. Alternatively, of course, taking the two extremes would be good.
That would be very interesting, and adding this data would really be quite easy. I can map all of it and include it in the regression, so we can certainly think more about what exposure we want to use. This is only to show the variation within a certain time period of cases, given that we will be using the sum. As I mentioned, I wanted to talk about mediation and confounding effects. The question I'm asking is not only what individual level factors may be associated with violence and asthma, but does living in a poor community, which we know is associated with more violence, does living in that poor community, is that also associated with other risk factors depicted in blue that are associated with asthma? And how do we control for all of the other risks of living in a poor community? How do we measure that? How do we control for the effect of where you're living, which is part, of course, of our analysis. So I want to talk briefly about how I'm thinking about doing that, and part of this is coming from the literature on community deprivation. This literature has used several key domains of deprivation, and for each domain they have proxies that represent something within that domain. So for education, for example, they're looking at the proportion of individuals living within a defined geographic area who have less than a high school education. For occupation, unfortunately, there isn't something for women, and I apologize for that, but they're looking at the percent of men in management positions or the percent of men in service. And service is construction, it's maintenance, it's repair, and it's food prep. I won't read them all, but for income, I wanted to point out that it's especially difficult. In the census and American Community Survey data, there is no really good proxy for wealth, and so several studies have taken multiple measures to try to approximate as best they can. And here are some more. Housing is again, difficult to quantify, and so you use multiple measures, including the value of the home, the cost of the mortgage, the monthly rent for the renter. You know, I should say that San Francisco is a unique city in terms of its size, in terms of its relatively small population, and of course in terms of the cost of living and the high proportion of residents who do rent. Even so, what I've found is that within the city there are gradations where there are more or less renters based on your neighborhood. So what I've done is I've quantified each of these outcomes for block groups within the city. Block group is the only level for which it's available, and I've mapped them. And I'll show a few of these images in a larger size so you can get a better sense. But I think that looking at multiple outcomes, you can kind of see that there are very clear patterns in terms of where things are clustering. So regardless of what it is, there are east, west, and north and south variations. So to give a more concrete example, this is percent fully employed, and that's the way I've defined it at present, and I'm looking at ways how I can more clearly evaluate employment and unemployment, or vulnerability in employment status. But this is people who have been fully employed working approximately 40 hours for almost 50 to 52 weeks in the year. And so red is 2 standard deviations above, meaning that those are the most fully employed populations, and blue 2 standard deviations below. You can again see our study population distributed throughout, living in regions of both relatively high employment and low employment. Here is poverty status defined as the percentage of households whose income is less than 125% of the federal poverty line. 125% rather than 100 has been used in studies where you're dealing with cities of relatively higher income, because your purchasing power will be that much lower. So red being areas where there is a higher proportion of poor families, blue being a lower proportion. And then in terms of demographics, this is one that I think I feel uncomfortable with, many people feel uncomfortable with. It's included regularly in the literature when discussing crime, poverty, education, and outcomes, and that's the percent white race. And I've coded for percent white rather than percent black, or percent people of color. There are a number of ways to kind of slice this pie. This is where it is now. You'll note that Latinos, according to the census, are Caucasian, so they might be included in this table. But our study population is Latino, so they would be white, and how to sort out the implications of that, I don't really know. So when I compare, I wanted to start with a comparison of what the outcomes I'm interested in look like citywide, what they look like in the block groups where our participants aren't living, and then what they look like in the block groups where our participants live. And again, this is a large table, but I think that the take home of this is that for every measure we're looking at, the block groups where our participants live are worse off than the block groups where they're not living. Okay, and that's something that I was personally curious about, although it's not adding to my analysis significantly, just to get a sense of when we talk about, poor Latino youth, this is what we're talking about. a higher proportion of people who have less than a high school education, a higher proportion of men working in service, lower in management. For some of the outcomes, unfortunately, at this level, I wasn't able to generate a result. So you can see for public assistance, comparing the two block groups, I couldn't generate with this point in my code. But again, significant outcomes in terms of p-values for almost all of our outcomes. However, when I look at block groups that have cases versus block groups that have controls, which would begin to answer the first question about susceptibility, are cases perhaps living in areas where there's higher violence and therefore more likely to have susceptibility issues? You don't see that difference. And in this, forgive me, in this table, crime is at the bottom, and you can see that there's a non-significant difference. But the same is true for almost all of the other community level measures that, as you can see, just eyeballing on the map, our cases and controls are living in essentially the same neighborhoods. So all of these community level covariates that we were thinking we would account for are not significantly different. I don't know why that's coming up. I think it was supposed to be in the inverse order. I was going to unveil the outcome result. And so, looking at crime, if I separate it out by block, I get this same distribution, kind of east, west, north, south, where red is 2 standard deviations higher in terms of incidence of assault relative to blue. We have cases and controls in both areas. Unfortunately, the cases aren't more likely to be in the red and the controls are more likely to be in the blue. They're evenly dispersed. When I cut it by block group, which would allow me to do the regression using ACS and census covariates, the distribution of assault in terms of its relative frequency changes a little bit, but I don't think it really, just looking at it, significantly changes the distribution of our participants. And
it's
so,
9:30.
forgive me. I should be wrapping up. So, I think that I want to use ArcGIS to go ahead with the analysis regardless of what I'm seeing here, to see what happens with susceptibility. But I think that we may find more when we look at severity in terms of level of control and or pulmonary function amongst cases. So essentially, rather than comparing cases and controls which are evenly distributed, essentially comparing the cases in red to the cases in blue and seeing if perhaps there's a difference there. So those are the association tests, that I described at the beginning: susceptibility between everyone, and then 4 cases, both control and pulmonary function. We'll be doing this geographically weighted regression, which is really interesting and really unique. It hasn't been done. The study that I described at the beginning, really it coerces your exposure into these artificial geographic units, right? And even though I've done the same to create these heat maps, when we do the regression analysis, we won't be doing that. We'll be keeping assault in its own free layer, and we'll be able to look at exposure to assault in your surrounding area, even if, for example, you live on the border of one of these block groups. You won't be forced into exposure in the rest of that geographic area, whereas it might be happening closer to you just on the other side of an artificial line. Does that make sense? And so, there is still a lot to be gained in performing this study, and I hope that, when we look at the cases, we'll find something. The last point there is, I think, more out of academic curiosity than anything else. In my slide where I described the model, I showed that living in a low SES community might be associated with other risk factors for asthma, including air pollution, smoking, and allergens. And we have a lot of that information at the individual level for our participants. And so, I've become interested in testing and seeing if, for our participants, if I use the ACS data, am I finding the associations that I expected? Do our participants, because we have that data, we can look and see if what other studies have suggested and what we, seems reasonable, we actually find in our population. So that's my last slide, just some thank yous to the Asthma Genetics Lab, including Esteban and Nita, who have been very generous in allowing me to perform this research project. It's really been a lot of fun. Louisa Holmes from the Center of Tobacco Control Research and Education has been indispensable in helping me understand how to use ArcGIS. The ProfPath Fellowship community has been really wonderful. And finally to CTR for having me here and for helping me get this year. So thank you all. Let me know if there's any questions.
The question, I'm wondering, this is something maybe unrelated to your study, but whether anyone's looked at the geographic distribution of asthma cases throughout the city, and whether that's something that's
All the cases?
yeah, just of like pediatric, like if there's clustering by geography at all.
I don't know. Do you know?
So it's hard to get that data because it's more of a, you have to go out in the community and do a survey. So there's estimates of what asthma prevalence is by geographic areas, but not actual amounts. The communities that have higher rates are not surprising. It's the Bayview 100 points. It's close to 25% of children have asthma. And to put that in perspective, the national prevalence of asthma is 10% in children, so dramatically higher. We do have information for geographically distributed for asthma hospitalizations, and there's definitely an association with neighborhood with that data. And so that's kind of how this came out. And I do like Peter's suggestion, and I don't know your name, about other considering other things and potentially creating like a SUND or more of a maybe a summative amount of exposure to small crime, because we talked about this before where assault's been the commonly used one, but it's also the tip of the iceberg. And what about the other small crimes? Where small crimes happen, there's probably bigger crimes happening that are just not being recorded.
Right.
And so we had talked about using police call volume, but that data is incredibly hard to get. And so it might be these smaller things, and especially since larceny and theft is really common in the city, that may help differentiate the cases and controls a little bit more, and would be something that would be interesting to look at a little more.
I think it's a great, like, the proxy that we use for violence exposure, I think it's a very interesting question. I think that using other crimes, we might change the border of where we have that red to blue transition, but given the high overlay between cases and controls, I don't know if we're gonna be able to distinguish those.
Yeah, well, you'd be surprised, because with our air pollution paper, despite the fact that cases and controls were so closely together, we did find a fairly decent association for asthma susceptibility. And I think it's that border theory that this is, you're artificially creating a border, which you've just
For the
alluded
heat
to.
maps,
Yeah,
right.
for the heat maps. And so what you're seeing in the heat map may not be actually representative of what's really going on, and,
Right, when we do
and
the
which is
geospatial.
exactly why we want to do the geographic weighted
Regression.
analysis, since they are able to take that into account, and it's not artificially limited by the borders. Instead, it's like, this is where the crime occurred.
It's
I'm gonna
continuous.
make a circle around where I am and wherever that crime was, and encompass those individuals that live near that spot.
Right.
And so, by including like larceny and theft, you may enrich the data so that you have enough power to do that. Because assaults are common, unfortunately, in San Francisco, but there is other things that may be more common, and by increasing the power or increasing the number of exposures, you potentially can increase your power of being able to detect a difference.
Like for example, larceny, I agree with Nita, larceny may seem benign, but it may be the tip of the iceberg in terms of, again, raising that sort of chronic activation. I'm living in a terrible neighborhood, I'm being robbed, I'm powerless to move out of this neighborhood.
Yeah.
Great, thanks man, that's awesome.